Thank you. We're going to make it. Hello, everyone. Sorry for the little delay. We got some network issues. So thanks for coming. We are going to see together why and how you should consider transforming your basic REST API into a data streaming API. So quickly, to introduce myself, my name is Audrey. I'm a developer evangelist at streamdata.io, and I'm also the co-leader in France of DevOps for Kids. I bet a lot of you have heard about DevOps for Kids. If you haven't heard about, come and we will talk about it. It's a great initiative to teach kids programming. So, modern times. For the last few years, internet has been more and more consumed on mobile devices, finally exceeding desktop consumptions 2 years ago. So we know applications that we develop have to be mobile ready. Even businesses want you to bring your own device movement. The problem is, the market application is now completely full, so it's become more and more hard for new applications to acquire users, and even more to retain them. So we really need to make our users addict. And we know that to keep our user interest alive, animation is the key. That's the reason why I'm using GIF instead of bullet points, even if I know you are all completely mad of bullet points. Sorry. But do you know why? Actually, it came from evolution. But when I say evolutions, I mean older than this. This guy here has learned a very important thing we still know. If it moves, it can be two things, food or danger. So in both cases, it might worth worrying a little bit about. And if it doesn't move, it's dead, no interest. Your brain just moved to something else. Sorry, kitty. So considering user interface, it's pretty fine. We know how to animate our UI. We got CSS3, every mobile application framework got animated components, even Material Motion has a dedicated part on animation. It's quite interesting to read, and one of the reasons why they recommend to animate our UI is hiding from the user what's going on behind the scenes. Because yes, the problem is when it comes to animate our data. So usually it begins with a lovely refresh button, which is not the best way to start a relationship with our user, because the user needs to interact as less as possible. And the problem with the refresh button is that usually it comes with the load of screen of the dead. And if this screen stays for too long, your user will probably feel upset, perhaps leaving the applications, and perhaps never come back. So we really need to stop using refresh button. Refresh button is evil. Forget about it. So in fact, all you need is turning your static API into a stream of real-time data. Because real-time user experience is what we expect from applications now. If you take a look at successful applications on the market, a lot of them are using real-time experience. Some of them are completely built upon it. So I take here as example Waze and Twitter and WhatsApp, but I could have mentioned Waze or Slack or Google Drive. It's already present in our day-to-day lives, and it's already what you are expecting. So now talking about solutions for real-time applications. When we are talking about real-time, usually 3 solutions are mentioned. The first one is polling and long polling. Who knows about polling? Yeah, a lot of you. The second one is WebSockets. Who knows about WebSockets? A lot of you too. And the third one is server sentiments. Who knows about server sentiments? Yeah, a few people, which is great. We will talk about it. So polling is this: making a request, waiting for the answer, making the same request, waiting for the answer, and so on and so forth. It works. Yeah, for sure, but you will probably make a lot of useless calls. You will retrieve empty response, you will retrieve the same data a few times. So, okay, you can make long polling and block the connection until something new happens on the server, but still, how are you going to deal if the connection is dropped? How are you going to retrieve data you have been missing? So polling is not a solution, neither is long polling. It's much more like a hack, and we should forget about it too. But true solutions exist. They are called push technologies. Both are under W3C specifications, and they have appeared around the same period. So, as you guess, if both exist, it's because they are a little bit different. We are going to see why. So, probably the main difference between WebSockets and server-sent events is that WebSocket is bidirectional, so it allows both the client and the server to send data to each other, whereas server-sent events is unidirectional. So basically, server-sent events open a channel where the data can be pushed from the server to the client. The second big difference is that WebSockets can handle both text and binary, whereas server-sent events only handle text. Looking at protocols, so WebSocket is using its own protocol, which is a TCP-based protocol. So its only relationship with HTTP is that its end check is interpreted by the server as an upgrade request. So the server will basically reassemble HTTP connections and WebSocket connections on the same port and switch to a bidirectional binary protocol, which has nothing to see with HTTPS. The good thing is server-sent events completely relies on it. So basically, you just need to add the text event stream header content type to your header, and it will work. So as you guess, talking about configuration, it means that when using WebSockets, you get to reconfigure proxies and load balancer, which is something ops are not really fond of usually. And there's a reason why. It's because a lot of proxies don't handle WebSockets very well. It could be a real nightmare to configure it properly. Server-sent events on its side, well, it's HTTP, so nothing to do. Looking at messages format. So for WebSocket, nothing is defined in the specification, so it's up to you to define your message format. It's up to you to parse it both sides. In server-sent events, a message is every line of text beginning with a data prefix. So it can be a single line message, a multiple line message, or a JSON object, all work. The very nice thing there is that server-sent events also define 3 other types of field. So the first one is ID, second one is event, third one is retry. Keep them in mind, we will talk about them a little bit later. Looking at implementations, they are quite similar. So to open a WebSocket, we are going to create a WebSocket object and pass the URL of the API we want to stream with a WS prefix as a parameter. To open a server-sent event connection, we are going to create an event source object and pass the API as parameter too. Then you can register to a few callbacks. The first one you could register to is onOpen, which could be very useful, especially for WebSockets, because opening a connection is made asynchronously, which means that it's prone to error. And you probably want to be sure that the connection is effectively opened before trying to send data to the server. Then you can register to the onMessage callback. So as we have seen previously, nothing is defined on WebSocket side, so it's up to you to parse it. And for server-sent events, you're just calling the data field on the object you received. And then you can register on the onError, so Captain Obvious there, not going to explain it. But the very nice thing is that server-sent events does not only allow to listen to messages, it also allows to listen to arbitrary event. So if you remember the event field we've seen previously, by putting it on your message, you're defining a type for your event, which means that you are able then to add an event listener on that specific type. Whereas you don't want to listen to all incoming messages, or perhaps you want to make a different treatment, you can make it easier this way. So, talking about streaming, we have to take care of what's going on if the connection is dropped for any reason. Sadly, in WebSockets, nothing is defined. It's up to you to deal with all that can happen, and all that will obviously happen. In server-sent events, we can combine 2 very cool features. So the first one is the reconnection timeout. It means that if the connection is dropped for any reason, your browser will try to reconnect to a server after 3 seconds. So if this delay doesn't fit your needs, you can just modify it with the retry field we've seen previously. So you add it on your message, and that's it. And then if you for example, on your message, if you have added an ID field, so giving an ID, a specific ID to each of your message, the browser, will be able to add this ID in its request as the last event ID it received. And so you will be able to retrieve everything from this point. So now, talking about browser support. WebSockets are natively supported by all browsers for a very long time, whereas server-sent events is only supported by modern browsers. Yeah. Actually, it's not a problem, because we got polyfill. And so we can easily support both older versions of other browser and Internet Explorer. And looking at Edge, it's under consideration at the moment. Looking at mobile browser support, so the same for everyone, only Opera does not support both technologies. So now talking about performances. So these numbers are coming from Matthias Nelson's blog post. So Matthias is the developer of an application called Birdwatch, which allows to visualize stream of tweets in real time. And so he first implemented his application with WebSockets because he needed to retrieve 500 tweets as fast as possible in his Play application. And quickly, he had so many issues that he decided to give try to server-sent events. So he made the implementation and then made this bench to check if performances were not worst. So first of all, he was a little bit surprised to see that for the same technology, there was such a big difference between implementation on different browsers. And then he noticed that server-sent events was very much efficient. The funny thing is, it took him more time to write the blog post than to write the implementation. So as often in programming, it's not that there is a bad technology and a good one. It's just that you have to choose the technology which will fit your need the best. So yes, if you're going to make a chat, for example, or a video game, probably WebSockets will be better. But if you just want to send data from the server to your customer, and if this data is text, and if the request, if the only data sent by the client can be handled by a post request, probably it's better to just use server-sent events. So that's the reason why we've created streamdata.io, which is a proxy available in SaaS mode. It's completely free. You can register, create your account, and make your tries. It's free until 10 million calls per month. So I think it will be fine. So it's based on server-sent events. We are going to make the following request for you. We are going to handle all errors that could happen. And we added a few features to make it more efficient. So first of all, we added a dynamic cache, which means that if your applications become very popular and the new users don't have to wait until the next call to retrieve data, they will be able to retrieve data from the last call. And then we have added incremental updates to reduce, again, the size of data which is sent. So to make this, we are using JSON-Patch. So first of all, just have a look at the schema. So basically, we are making first request. And if on the second request, for example, nothing has changed, we will not send any data. There's no sense to send something you have already received. And if the third call, for example, only two fields of your document have changed, there we will make incremental updates. So we are using JSON-Patch, which basically defines a set of operations which can be applied to a JSON document, so it can be replace, remove, etc. And so let's imagine, as we have seen in our schema previously, that on the first snapshot we received this document. But on the third call, only 2 fields have changed. You will receive this instead of the whole document again. Then you just have to use a JSON-Patch library, a few exist, to apply those changes to your document. Great, so now we are going to make a demo. I got this drone there, which I would like to make fly on the Bitcoin value. So I'm going to use this API, which gives me the average, the average of the Bitcoin in euro, meaning that the field here, which will be interesting for us, is the last field. It's the last value a Bitcoin has been sold in euro. And okay, so I'm going to connect to the portal. And I'm going to remove this one and create a new application that we will call demo. Okay, once I've created this application, I can just take my API and paste it there. Okay, so as you can see here, a token has been generated, and to start streaming this API, I got to call the portal, then my API, and give my token. So I can just copy-paste the curl command which is there. I'm going to paste it in a terminal so that you can see what it looks like. So here we retrieve a first event called data. So that's my first snapshot. And then we retrieve patch event with the JSON-Patch format. Fine. So once this is done, I can go back to the My API section and edit the polling frequency. So here is the place you are going to give all parameters you need, HTTP headers, query parameters, etc. So let's say I would like to poll every second. Save, and if I'm coming back, the new polling frequency has already been taken in consideration without closing and reopening the stream. So, fine. Now, let's go to the code. So here it's a very basic Node.js application. I'm just going to use 3 libraries: an event source library to create an event source, a JSON-Patch library to apply my patch, and the IO drone library to pilot the drone. So first of all, I'm going to need an options object to define my IP and to pass it to the drone. And then we are going to create a drone client by calling our drone create client with this option object. There we are going to create an event source object by calling the new event source with an URL. Okay, so here I'm just copy paste my call command as I already got the URL I need. Okay, fine. Then I will need a data object and a last object to store the last value we are going to check. So once this is done, I'm going to add event listener first on my data event. So here I'm going to receive a snapshot. So my data object will be JSON.parse snapshot.data, calling the data field. My last value will be data.last. Once I received value, I will let the drone to take off. And I'm going to log what's going on so that we can have an outcome. So it's first, last. Fine. So now I can add another event listener on the patch event. Here I'm going to retrieve a patch. So I'm going to store it in a local variable to just make the parse. Then I'm going to use my JSON-Patch library to apply my patch to my data object. So it's my patches object. Yeah, not necessary. And then I'm gonna, so my data object has been updated at this point. So first of all, we are going to log its new value. So let's say it's a patch last. We're going to take data.last, and then we're going to make the comparison. So if, for example, last is under data.last, it means that the Bitcoin has gone up. So we're going to say up, and drone.up at a speed of 0.5. And if it's not the case, it means that it's going down at a speed of, so let's make the drone going down at speed of 0.5. So then we reassign our last value, and then we can register to could be useful to register to the error event in case something went wrong. So up. So here we are beginning by logging. Then we are going to say the drone to land, and we are going to close our event source. And well, we don't want the drone to continue flying after the session, so we are going to say after 30 seconds. It's almost the same, land, close, and just a little log to see what's going on. Okay, so first of all, I'm going to try my code just to be sure I didn't screw up. Okay. Yeah. Thank you. Okay, should work better. So you retrieved the data, and did you receive the patch? Yeah, fine. Okay, so now the tricky part. So my drone was broken, as some of you have perhaps seen. Nice guys have fixed it this morning by making a patch, so I hope it will work properly. So we have to wait for it to start. So now I'm going to try to connect to it. So here it's the part where you just cross your finger so that there is no network connections. And it looks like there is network connections. So, sorry? Thank you. Yes. So now, okay. So let's go back to the code. So that's the first time it makes this. Yeah, no, the connection is fine. You are still on. Oh, perhaps that was that. That was that. Okay, first last, taking off. Then we have to. So I hope the Bitcoin will go up, otherwise it will be. Yeah, fine. So if you got Bitcoins, it's time to buy them. And not too up, just. Well, okay, you get place. Just. Yeah, thank you. Goodbye. Thank you. So I had to say a big thanks to this guy this morning who saved my life. So I hope I convinced you that server sentiment is a great technology. If it's the case, you can vote for its support in Edge by click on the link with this code. Thank you very much. We got 2 minutes and 30 seconds left for questions. We got some. Thank you. Do you want the drone again? Perhaps we can make something fun. We can just, for example, so drone.up, let's say drone.animate, flip ahead for, let's say, 3 seconds. I like you very much, but not just up my head. Oh, I think, yeah, is a little bit sensible. So. It doesn't appreciate to be moved. Thank you. fine. Okay, let's hope it's going up. Let's buy some big coins. That's the moment. You're quite ridiculous when you're doing that. Yeah! Woo! No, 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 come here. Oh! That's real time, no cheating. Thank you very much.